Hello, I'm Bradley Alicea, and I'm going to give an overview of our 2023 activities in the DevoWorm group. This is going to be a presentation at the annual update for the OpenWorm Foundation. So it's going to go through our activities throughout 2023 in the different areas that we've been active. Our website is devoworm.weebly.com, and our GitHub organization is github.com/devoworm. And let's get started. So the first thing I'd like to highlight is our involvement in Google Summer of Code. So for this year's Summer of Code, we had two students, Sushmant Reddy, and his project is New Directions in DevoLearn. So we've been running the DevoLearn project for several years now, and his project focused on improvements to DevoLearn, the platform, improvements on our hosting, and improvements on our models, and incorporating new directions in our models that we have to offer. So DevoLearn, for those who don't know, is a deep learning method for segmenting cells. We try to specialize it for developmental systems. Sushmant's work involves segmentation, improving the segmentation techniques, and improving the performance of the deep learning algorithms that we use. He's also been good at finding ways to improve the project that are beyond the scope of what he's proposed. So he put all our models on Hugging Face, and he also has been working with a model from Meta, which we'll talk about in a little bit. The second student is Himanshu Shogul, and he actually joined the Orthogonal Research and Education Lab last year as a GSOC student, and he worked on our open source sustainability initiative. And so he joined DevoWorm this year, and he worked on our developmental graph neural network project. And he basically worked on the pipeline that we have to go from raw data to building graph embeddings to what he actually ended up doing was topological data analysis. And so we've got some of those things in place now. It's a pipeline that feeds into the DevoLearn platform. So ideally, we're going to use the segmentation power of DevoLearn and then have another layer where we do graph neural networks and topological data analysis and the like. So the improvements to DevoLearn were a multitude. We have our projects up on Hugging Face. Sushmant uploaded 3 models. So there's the nucleus segmenter, the lineage population model, and the membrane segmenter. So this is where you take images of cells in an embryo marked with GFP markers or something like that, and you can extract different features. So you can extract the nucleus, you can extract the membranes, and then you can actually build a model that matches the lineage tree of an embryo. So those 3 models are hosted now on Hugging Face. We have an organization there, DevoWorm Group, where our GitHub is github/DevoLearn, where we have all of our software, all of our documentation for both of our GSOC projects. And then another thing that Sushmant worked on was CellSam. And CellSam is a model based on the Segment Anything model, or the SAM model, that's Meta has released recently. And so he's been an early adopter of that model, and he's been able to fork it and create this bounding box prompting model. So basically you prompt the model with a bounding box, or we're also looking into prompting it with some sort of text prompt like nucleus or membrane. And so it would be able to segment these things based on a simple prompt. And so this is something that Sushmant is working on. He doesn't have it perfected yet. Sushmant is actually trying to do like a post-bac with the group. So he's trying to gain experience for his graduate studies. And so this is a good example of something he's driving forward on his own. And I encourage him to continue to go in this direction. And if people are interested in doing a post-bac, please let us know, because this is something we've done a number of times in the group. It helps people gain experience for graduate studies or for industry, and it helps us drive some of our initiatives forward. Himanshu's project, of course, was on what we call developmental graph neural networks, or DGNNs, and topological graph learning. And so he took an off-the-shelf package, TOGL, and he worked on modifying it for our purposes. He's been working on developing methods for graph embeddings. Jiahong Li, who was the student in 2021 for this project, he was able to develop a pipeline that had 3 stages in it, and Himanshu developed things along those lines, working on each stage and contributing in that way. So on the left, you can see that there's the cell segmentation step. Himanshu experimented with different segmentation techniques and tied his work into DevoWorm a little bit. We'd like to maybe next year tie it more explicitly with some of the advances going on in DevoWorm in terms of cell segmentation. But then we also are able to produce graphs. So here we have this birth versus lifetime graph, which is a common graph in topological data analysis. And you have these segmentation volumes, these 3-dimensional volumes that can then be turned into a graph embedding. So this is available on our DevoWorm site on GitHub, the DevoWorm repository, and the DevoGraph. It's actually a DevoWorm organization, the DevoGraph repository. So next I'd like to talk about the papers from the group that we've worked on or published during 2023. So the first paper I'd like to focus on is this paper from a special issue of Royal Society Interface Focus called Making and Breaking Symmetries in Mind and Life. And this was published by myself, Richard Gordon, and Jesse Parent. This is the special issue cover here. This is an image that Michael Levin designed in Midjourney. So it's a generative AI type image where he prompted it with the term making and breaking symmetries in mind and life or something similar. And out came this image, which looks vaguely biological, but also vaguely sort of classification-like. So you're classifying like neurons or something, and there's a tree. And so, this is a nice image for cover. The special issue itself focused on a number of topics in biology with respect to symmetry. So we had a lot of papers on complex systems, papers on evolution, papers on development, papers on neuroscience, and sort of the role of symmetries and complexity therein. And so our paper, Embodied Cognitive Morphogenesis as a Route to Intelligent Systems, focused on a lot of the work we've been doing in the group on differentiation trees, on modeling of tensegrity, and other things like that. So, this will be a good paper to check out if you're interested in that. We also sort of gave a 4E treatment of development. So 4 E's are embodiment, embeddedness, extended cognition, and extended morphogenesis in this case, and activism. And so this is something that if you're interested, get in touch with us. This is a very interdisciplinary type thing. We're going to be following up on this paper in the next year. The second paper is an ensemble approach to the origin of life, and this was by myself, Bashir Ahmed, and Richard Gordon. Bashir is not in our group, but he contributed to the paper. And this is in a forthcoming book chapter. And so basically what we did was we did a lot of modeling of the origin of life. We had this ensemble approach, which is sort of inspired by statistical physics, whereas, you have an ensemble of things, of simple phenotypes or of chemicals, and we can model this using computation or agent-based modeling to show that life can arise from basically precursors or even nothing, as long as we have an ensemble of things there to bootstrap from. And so this is it's a very long paper, a lot of details in it, and we're also interested in the origin of life. So this isn't something we did a lot of this. We did a lot of it this year, but not in terms of developing more work on it, presenting at conferences or putting out papers. So if you're interested in this kind of thing, also get in touch. Then we had another book chapter. This is in the Mathematics and Biology of Diatoms. This is by myself, Richard Gordon, and Jesse Parent. This is a paper that kind of focuses on our work on diatoms, but sort of thinking about the psychophysics of their sensory world. So, we focused on their movement before, on the biomechanics of movement. on the, analyzing movement from images, but not really considering the sensory world of the diatom and how that translates into movement, and then some of, thinking about that from a psychophysical perspective. So, this allows us to think about statistical regularities in sensation, and, hopefully maybe that can translate into statistical regularities in movement. This paper was largely theoretical, so it didn't have a lot of data attached to it. Nevertheless, it's a good paper to read if you're interested in single cell morphogenesis and linking that to behavior and other types of mechanisms. Now, diatoms don't have a brain, but they do have molecular pathways and they do have cellular signaling. So these are the kinds of things we're drawing analogies to. The next paper was hypergraphs demonstrated anastomoses during divergent integration, and this is available on ResearchGate. This follows up on a lot of the network work that we've been doing over the past several years. We use this construct of hypergraphs, which are graphs within nodes of other graphs, and it allows us to model things that are very complex, have multiple layers of sort of network structure. And so what we do in this paper is talk about embryogenesis as both a process of a lineage tree unfolding over time and a connected graph. And so divergent integration refers to the divergence of cell types and tissues in an embryo that's, starts out that's undiverged, or just a bunch of stem cells or developmental cells. And they're usually connected by maybe signaling or proximity. And as they diverge, as they migrate around the embryo, as they turn into other cells that maybe turn into other tissues, they become divergent, but they're also integrated in the same organism. And anastomoses refers to the connections between divergent components. So cells will diverge from a single set of stem cells into a population of connectome cells and a population of muscle cells or muscle tissue. And so these things are still connected in the organism in different ways through nerve projections and through other cells, supporting cells. And so those connections then define that graph. They define a lineage tree, but they also define a spatial graph. And so we talk about that methodology in that paper. Then finally, there's this paper, Differentiation in the Molecular Order of Self-Organizing Developmental Codes. And this was myself, Richard Gordon, Natalie Gordon, who's not in our group but contributed to the paper, Susan Crawford-Young, and Lucas Bastani. And this paper focuses on the molecular bases of differentiation in 4 different organisms: C. elegans, Drosophila, yeast, and mouse. And so we focus on mosaic development, which is something that's unique to C. elegans and to Drosophila to some extent, and compares that with regulative development in the mouse and no development in yeast. And so we use secondary data for a lot of this. We also did some modeling. We're still working on the details of it. We had to do some revisions of it, but it's in progress and should be out sometime next year. And so we also have some lectures, and some of them were at conferences and some of them are hosted on our YouTube channel. Earlier this year, I created a number of YouTube lectures on some of the stuff that we've been doing in the group because I want to advertise some of that work. And so this is the first one. This was at Dynamics Days 2023. And that happened way at the beginning of the year in January. And it was hosted in person at Trinity College in Connecticut in the United States, but it was also hosted virtually. And so I was able to give a talk on something called Physical Intelligence and Development, Regulation of Dynamic Tension and Sensing is Intersecting Networks. This is something that is kind of related to that hypergraph work that I talked about earlier. It's a little bit more in terms of function instead of like structure, but it was an interesting talk. I think it was well received. So Dynamics Days is a nice conference filled with mathematicians and physicists and dynamical systems people, but also you have, biologists and other types of people there as well. So it's an interesting talk. It's on YouTube, so you can check it out there. I also did a number of YouTube videos that were kind of on these topics that we were doing that I wanted to advertise to people. So we had embryo networks, computational development, and neurosimulation. This was from I think January, and this talks about a lot of the embryo network work that the group has done over the past several years. We also done work on computational development in general, and then this idea of neurosimulation, which ties into what's going on in the orthogonal research and education lab. And so we've been doing a lot of stuff with neurosimulation there and tying that all together. The second one is digital diatoms, biophysics and information processing. This is from some of the work we've been doing on diatoms over the last several years. So we've done work on diatoms, we've done computational modeling, we've done sort of biomechanics and physics of movement, and we've done some machine learning on it as well, and some diatom videos. And so this is really kind of digging into this work a little bit and looking at all the aspects of diatoms that we find interesting, and we've published a number of works on them. So we can't forget our weekly meetings. This is kind of the heart of what we do because we like to bring people in and have them participate on a weekly basis. So this is where we have our a screenshot of one of our meetings. So, we have our meetings in Jitsi at an address at 10 a.m. Eastern Time in North America on Mondays. So every Monday morning we have this meeting, or this in North America, it's morning, and we're joined by people from all over the world. And so we have a number of different things that we cover in this meeting. And so this is an example down here of our Slack channel alert that we always send out every Monday. We just tell people that it's happening and they can join in if they would like. We have some regulars usually join us, but we also enjoy people coming that are new. So the topical reviews we've covered this year were, had to do with origins of life in embryos, synthetic biology in embryoids, single-cell morphogenesis, soft materials, and collective cell physics. So we've done a lot of stuff with cellular physics, with embryoids, with organoids, and single-cell morphogenesis this year. So we haven't done a lot with C. elegans per se. Then there's, we have these biology and computation updates. So one of the points of these meetings is to get computational people in contact with biologists or developmental biologists, other types of biologists, and vice versa. So we have this, I consider myself to be a computational biologist. And so I can bridge these two, and a lot of, we have a lot of expertise in the group. We have people with backgrounds on physics, people with backgrounds in engineering, people with backgrounds in computer science, but also people with backgrounds in biology. And so we can bring those things together in our group. And so these updates kind of focus on some of the latest software developments. So we have people actively working on software simulations, on deep learning, on machine learning, but we also have people doing, interested in just featuring what's out there. So, giving presentations on some of the latest techniques. We also focus on computational models. We just don't do deep learning and machine learning. We do a lot of things with agent-based modeling, with cellular POTS models, with other types of physics models. Susan, who's pictured here, she's been working on tensegrity models, or models of dynamic tension, stability under dynamic tension. And of course, we do bioinformatic analyses. That last paper I talked about from this year is actually an example of that. So we're, have a strong interest in bioinformatics and making use of secondary data. We also have tutorials to that end. We have different tutorials on different topics depending on what people are interested in working on. This year we had tutorials in topological data analysis and developmental deep learning. So thank you to our contributors who joined us during 2022-2023, and thank you for your attention.